Today we are going to be making a banking app. Just kidding, we are only going to write one endpoint. And this is not because that we need another REST API video, but mostly because of the fact that I have slowly become more of a prompt engineer whose only job is to click accept all, rather than someone who actually knows and understands his code. So in this video, we are going to make a really cool API which generates captions for any image under the sun. And we are going to do it without cloud code or cursor holding our hand. Let me show you how it works. So here I am inside Postman, and we have got our server running on port 3000, and slash API slash caption is the name of the endpoint that we are going to hit, and it accepts inside its request body an image uploaded as a multi-part form data. So let me also show you the image that we are going to test the API on. And this is the one. So we have got a person wearing a black dress and they are on a snowboard, and there is a nice scenery of snowy mountains in the background. So if we come back to Postman here and try to upload this file and send a post request to the endpoint, we can see that it has generated a caption: a snowboarder is going down a snowy hill. Fair enough, right? And most of all, this setup does not require you to get an OpenAI API key or an H100 GPU card by selling your house. Let's start by setting up our project. The choice of package manager is Yarn, specifically Yarn 4, and we are going to initialize the project by writing yarn in it. So what this is going to do for us is create a package.json file which has all our dependencies listed as well as the scripts that we are going to use throughout our application, and a yarn.log file which contains the exact versions of our dependencies so our builds are reproducible every single time. And we are also going to do one small thing is to set the linker to node modules. So what this is going to do is remove the default plug and play system that Yarn offers and fall back to the original node modules directory for packages which we are familiar with. We are doing this because PNP is too complicated of a system for the problems it's trying to solve. And if you use multi-stage Docker builds, it creates a lot of problems in there as well. So we are going to remove this file now, and let's start by installing the required packages. And let's also install TypeScript and the types required for these packages as well. Notice the -d flag here. This means that these are development dependencies, and we're not going to be shipping development dependencies inside our production image. And it makes sense, right? Because the final image is going to have the transpiled JavaScript files and not require TypeScript at all. So we are also going to be using the modern ESM syntax, and to enable that we have to add another key inside our package.json file by the name of type, and we have to set it to module. The reason we are doing this is because CommonJS is node specific and ESM is more universally compatible with other browsers and other runtimes, for example Bun and Dino. And besides, it's got a much nicer syntax compared to the old require syntax that we use in CommonJS. And if you're going to start with a new Node.js project now, it's better we stick with ESM. With that out of the way, let's also create a tsconfig file which is going to have all our TypeScript settings, and we can do that with the tsc utility. So let's do that. So this creates a tsconfig file for us. I have looked up all the recommended tsconfig settings on Google right here, and these look good to me. So we are going to copy these and replace all the contents of the tsconfig file by these particular settings. Let's also create a .env file and this is going to have information that we want to inject in our application on runtime and not hard code in our code. And if you are working with secrets, then your deployed application should access them through a key vault or a secrets manager or something similar, because if someone exports your application's ISE template in Terraform or Bicep, then if you have used plain environment variables, all your keys will be appearing as plain text, and which is not good, right? The security of your application is going to be compromised. But from a local development perspective, all we have to do is to add this file .env file inside gitignore. We are going to do that, but we're also going to add an exception for env.example, and this is because if someone else clones our code, then they want to know which environment variables exist so that they can substitute their own. So we have added this exception. So let's add an environment variable inside our env file. We can start by adding port, which is 3000, and this is what we are going to run our server on. We can copy this file and rename it to env.example, and this is something we are going to commit to Git without the variable values. Now before we continue, let's first commit our work. So we are going to stage everything and then add a commit. Now that we have committed our work, let's start by creating a minimal web server which is going to start listening for incoming requests. So this is going to tell us if the server is even running or not. So for that we are going to create another source folder inside our project directory and create a file by the name of index.ts, and this is going to be the entry point inside our application. Now if you remember, we installed Express in the beginning of our video, and Express is a minimal web framework inside of Node.js which provides basic routing, middleware and HTTP request capabilities. So let's start by importing it. And we are going to create an instance of the Express class that we are getting from the library. This app object that we have instantiated right now is going to be utilized to define routes, middleware and actually start the server. Let's also add middleware to parse JSON inside our server. So what this line of code is doing is adding middleware which is going to let us parse incoming requests which have JSON bodies. And it's strictly not necessary for our server since we are only going to upload files, but this is something more or less you are going to utilize in most of your applications, so may as well. Now to start our server we require a port, and we already defined a port variable inside our .env file. So to load up all that we require the .env package. We are going to import that on the top. And let's define a port variable here using process.env. So this is going to retrieve the port variable from our .env file. Now once that is out of the way, we are going to define a simple health endpoint which is going to respond if the server is running. So let's create that, and we are going to have it listen for GET requests, and inside the callback we have request and response, and for the response body we are simply going to return a status of 200, and inside the JSON body we are going to add a line saying status is up, and optionally we can also return a timestamp just for good measure. We are going to utilize the JavaScript date class for that. Now that we are done with the bare minimum, we can have our server start listening on port 3000 or whatever we have entered inside the .env file, because usually if you are deploying on platforms like Heroku or Render, they will give their own port variable and your application will adjust as per that. And inside the callback function, we can add a simple log stating that the server is running on the specified port. Save the file, and now we can try to run this server. So I'll specify the path here, and we can see that the server has started listening on port 3000. Scripts like this, for example, starting the server or building the source code or running database migrations, are something that we are not going to write again and again by hand. So let's make a shorthand for this inside our package.json file. And for that, we have to create a new key by the name of scripts. And inside in the scripts object, we are going to create a dev script. And unlike node that we just used now, we are going to use tsx. And the reason for that being, tsx is going to watch our source files for any changes, and as soon as it detects any changes, it's going to automatically restart the server instead of having us to manually do it again and again, which is really helpful in development. And let's also move this type module here above for the sake of readability. And let's try running our server using our specified script. My bad, we forgot to install tsx, so let's also do that as a dev dependency. And now we can try to run our script again. Let's go, our server is running. Let's try a quick curl to see if the health endpoint is responding. So we are going to open a new terminal here and run curl localhost 3000, because that's where the server is running, /health for the health endpoint, and it is returning okay. And this is actually interesting because we are returning the status and the timestamp of the server, and yet we are getting only okay. So if we go back to our terminal here, it is stating that it cannot set headers after they are sent to the client. That means that the HTTP status of 200 is already sent to the client and it cannot modify the JSON body after that. So what we need to do is change the send status here to just status and save the file. TSX will automatically restart the server for us, and let's come back to our old terminal. And now we can see that we have the status as well as the timestamp of the server during the request inside our response. Let's start writing the router, which is going to have a captions endpoint. So for that, we are going to create a new folder inside source by the name of routes, and inside this folder we are going to create a new file by the name of caption.routes.ts. So a router is basically like a mini express app. The difference is that it only knows about the path that is assigned to it and nothing else. So to use this, we are going to require the router class from express, and let's also import request and response since we are going to be needing them anyway. And let's create an instance of this router class. And for this router, we are going to create one endpoint which is going to accept post requests. Let's keep the path as root. And we can keep the callback as empty, but let's send a dummy response so that we can see if everything is working properly. Finally, let's export this router so that it can be used inside our startup file. Now let's come back to our index.js file and import this router first thing. And one of the things that I want you to remember for later is the sequence of application startup. The middleware is always going to come before the routes. So for example, we have got the Express JSON middleware, or maybe in the future you may have your authentication middleware or something like that. All of those things come first, and only after those we are going to mount your routes. So to mount the router, we are going to use the use method of our Express app, and the first argument is basically the path where we are going to mount it. So let's keep it API/captions, and the second argument is basically the name of the router. Let's save the file and let's do a quick curl to see if everything is working properly. Great, our router is working perfectly. And the reason we are going through all this hassle of creating a router is because routers keep our startup file clean and single purpose. Later, maybe you could have 100 endpoints inside your server. You're not going to keep all of them cluttered inside one startup file. That will be a nightmare to maintain. So, this pattern keeps our app modular and flexible to future development. Now, obviously, this is a fairly simple way of doing things, and clean architecture is a different science in itself, where you've got different design patterns like MVC, repository, CQRS, just different ways of organizing and maintaining code. But that's where things get really opinionated, and I would like to not discuss them in this video. That deserves a separate talk on its own. Before we move to file uploads, let's commit all our work until now. So we'll stage everything, then we'll add a commit message. Done. Now let's take a moment to talk about Multer. So when we are working with Express, we know that it can work really well with JSON and query parameters. But when it comes to multi-part form data, like the image binaries that we have, we are going to require Multer. So let's start by importing it. And this multer here is a factory function, and it's going to provide for us an object which is going to give us many methods to handle file uploads. To understand Multer's API, I have come to its npm page, and if we see here, it's a really popular package. It's got around 12.5 million weekly downloads, and it says here that it's a Node.js middleware for handling multi-part form data. That's exactly what we need. So if we scroll down, so here we can see the documentation on the options object that we just talked about, and it accepts these many keys. And the ones that we are interested in today is the dest or storage key, because this is going to tell Multer where to store the files, and the limits key, obviously because we don't want the user to upload their entire house on our server. So let's scroll down and look for usage. Now for storage specifically, we've got two options, the disk storage engine and the memory storage engine. And as the name suggests, disk storage will allow you to store files on your hard drive. And below we have got the memory storage engine, which is what we are going to use, because really we're just going to hand over the file to the model and forget about it. But even if I did want persistence, I would still go with memory storage and upload the raw buffer that I'm receiving to a storage account or an AWS S3 bucket, something like that. And then finally take the link that I have received from there and store it inside a relational database. Because this storage is not going to survive container restarts. And if you've got multiple instances of your server, then you never know which one has the file. So let's take this code snippet that they have given here and paste it inside our VS Code. Next in line we have the limits key, and this one too accepts an object of various optional properties. So if we look at this table, the one that we really care about is the file size key, and it says in here that we have to input the file size in bytes. That means if we go by a reasonable assumption of 5 MB per image upload, then we know that each MB is 1024 KB and each KB is 1024 bytes. We multiply all that by 5 times, and this is the expression that we are going to put inside our file size key, for our multi configuration object. So let's add this as well. And then let's just add this key inside our options object as well. All good. Save the file. So now we can modify our route to use the new middleware. So we can come here inside route definition and add our upload object. And this single method here, it's going to tell Multer to expect only one file, and this image is the name of the form key which is going to contain the multi-part form data. So the client has to send exactly this, otherwise they should get a validation error. So let's also add a validation check here as well. Here we could simply send a status code of 400, and inside the JSON body we could provide a helpful error message and return. So if I come to Postman now, and inside this request body, if I remove this file and send an empty form key, the server says bad request, and inside the response body we get our no image provided error. And if I put back the image and send the request again, we can see that it says status received. So our validation seems to be working. Alright, now on to the model. And this is the most fun part of the video, and we're going to see a lot of cool stuff. But before we do any of that, let's first commit our work. So let's stage everything and add a commit message. All set. Now we can proceed. So I am here at Hugging Face, and the model that we are going to be using is this VIT GPT-2 image captioning. And this model is capable of taking an image input and generating a caption for that. We'll see how this works in a second, but I mentioned to you that we will not be requiring any API key or a powerful GPU card to run our model. And that's because this model is really lightweight, and we are going to download the weights and run it entirely inside our Node.js server. Now if I go ahead and click on use this model here, it provides an option for Transformer.js. And this is a library that lets you run popular machine learning models in a Node.js runtime. So if I click on that, it gives me a small snippet, and let's copy this and let's create a script for a one-off download. So inside our source folder, I'll create a new folder by the name of scripts, and here I'll create a new TypeScript file, and we will paste everything that we copied from Hugging Face. And let's also add Hugging Face transformers while we are at it to our dependencies. Now that we have it installed, let's add one more import, which is the env object, and this is just a configurations object which will allow us to set model path. And using this, we are going to set our cache directory, which is basically the place where the weights will be downloaded, in a folder by the name of models inside source. And let's add a line of log for just reassurance. Okay, and this is yet another good example of a script which we can create a shorthand for, because in the future we are going to download the model for some other instance, or maybe some other developer is trying to run our code. So they are going to be able to do that without going inside the logistics of transformer.js or pipelines. So we come to our package.json file, and herein we add another script by the name of download model, And let's have tsx executed. Now we run this script. Alright, so the download was completed and we now have a models directory inside our source. So allow me to explain what we just did. So if I expand this folder, we have another one by the name of Onyx, and these are the weights of the model. So what do I mean by that? Weights are just floating point numbers that a neural network learns during many rounds of training or epochs by a process called as backpropagation. And the really inspiring thing about all this is that someone collected a lot of data and spent a lot of time and GPU compute for training this model. And once they reached a performance that they were satisfied with, they decided to open source the weights for someone else like us to use. And these Onyx files that you see right here, it stands for Open Neural Network Exchange. And that's just a standard agreed upon format for sharing and exporting machine learning models. The library that we are using for inference, transformers.js, also requires our models to be in Onyx format. If you have got your own model, one thing you could also do is to export it inside Onyx format and then use a library by the name of Onyx Runtime Web to run it inside any web app. Without going into too many details, there's just one more file I want you to pay attention to, no pun intended, is the config.json file. And this file is basically the TLDR of the deep learning model that just got exported. It has information about how many layers are inside the model, how many neurons per layer, what are the activation functions that have been used, everything. Take a look at this file and I believe it's going to give you a very decent picture of what this model actually is. But for now, let's scroll up and we are going to take a look at one such property, that is the architectures property. And it says here vision encoder decoder model. What does that mean? It means that this model VIT GPT-2 image captioning is not a single model but rather a combination of two different models. VIT, the vision transformer, which is our encoder, and GPT-2, a text generation model, which is the decoder. So the idea in very simple terms is when we pass an image to this model, VIT is going to look at the image and create a feature vector for that image representing what's inside it. And that vector is going to be passed to GPT-2 and it's going to look at the entire feature vector, which is basically an n-dimensional array of floating point numbers, and it's going to generate one word or token at a time and keep on predicting the next word based on the previous token. We refer to that as cross attention, and the models that we really like, for example Claude and GPT, they also run along somewhat the same lines. Here is a very simple diagram I made to illustrate this concept, but this is just straight ML that we are using to make the API. If you want to learn all of this seriously, there are a lot of good lectures on the internet which go into great details of how all this works. For the sake of simplicity, I have avoided all that. And while we are at it, let's also add this model directory into our Git ignore because it's pretty large, about 900 MB, and we don't want to push all that inside Git. Alright. Now let's move to our service layer implementation. So we'll go to our source folder, create another one by the name of services, and inside here we are going to create our service file. And in here we are going to borrow a lot of stuff that we have inside our download model script and paste it here. And inside the imports we are going to add another one by the name of image to text pipeline. And this is basically the type of our model inside transformer.js library. Then let's add a variable to hold the model instance. And we are going to set this as null initially because we plan to lazy load the model on first request instead of during server startup. Now let's wrap the model load inside a function call. and it's going to return a promise of type image to text pipeline because that's what the type of our model is. And inside the function body we are simply going to take our pipeline call and keep it, and we are going to assign it to our captioner variable. And in here we are also going to add a third parameter which is going to instruct transformer.js library to load the model weights from our file system only. And if you can see from the IntelliSense, we have got this object by the name of local files only. This is the one. So we are going to set it to true. Finally, let's return this model that we have loaded. Clear out the logs. And since we are going to lazy load this model, we are also going to add another check to see if the model isn't loaded already. And what this is going to do is to see if the model is already loaded, and if so, it's going to return the same captioner variable, and if not, it's going to call the pipeline function and load it. And now let's add another function which is going to utilize our get model singleton and actually generate a caption. First off, we load our model. Now I found out that there is a catch with how the model accepts its input. And the problem is that we are receiving a Node.js buffer from Alter, but the model wants a blob object in order to make predictions. Browser API cannot directly convert buffer to blob. So we are going to have to cast the buffer object to a unsigned integers array, which is the JavaScript standard for most browsers, and make a blob from that. Quite a mouthful, so let's just do it. And then we make a blob object out of this array. Finally, let's send this blob object to the model to get a caption. And I get a TypeScript error here. Okay, so let's add a wait to load the model, and now that's gone. Now the output of the model is a JSON object with many keys, and we are only interested in one, so let's just grab it. And we can see that the generated text key here is the one we want. And this pattern is very similar to what we see in OpenAI as well, right? Because the first object of the result is usually going to contain the chat completion or prediction that we want, right? And the rest of the keys are just metadata. So we'll take what we need and discard the rest, and that's our function completed. All we need to do now is to take the export in our route and call the function. So let's go ahead and do that. And below we just replace our basic status received response with our service call. And replace this object by our caption, and we have a TypeScript error. Okay, so we'll await this, we'll mark this function as async. All completed. A quick side note on the singleton pattern that we have used here. So the way how it works is you initialize the resource once and you reuse it on every request, be it database connection, be it machine learning models or Redis instance, whatever. And for most small to medium sized projects, singleton pattern takes us very far. But there is a very valid criticism to this approach, and I think you should know it, and that is that it tightly couples object creation with object behavior. And in a large code base, how you would do this is by passing this model or any other dependency inside the constructor of a class. That is an advanced design pattern which we call as dependency injection. And in practice, it is not as bad as it sounds because the DI container manages your object creation and deletion life cycles. And it allows you to mock your dependencies and independently test the business logic. For example, if you wanted to swap the implementation entirely, you could do so with the help of interfaces. And this is something I would like to cover in a future video. Let me know if you're interested to watch that. But for now, let's proceed to testing. So let's start up our server and open up Postman, and inside the request body, let's select a different image. This time we have an image of a barn. We'll send a request to our endpoint. So we do get a caption, a farmhouse with a barn and a fence. But this looks a bit ugly and it doesn't have a key attached to it. Let's go back and wrap the caption inside a key value pair so it's easy for some client to consume. And now we have a good looking JSON body. That's perfect. One more thing, let's also wrap this service call inside a try catch block. And inside this catch block, we are just going to console log the error and send an internal server error back to the client. So this way what happens is, if something unexpected happens, we can always go back to the log stream and check the logs. But we send no such internal details to the client that could compromise the security of the system. Now come back to Postman and send again. And we get our caption back. So we come back to our terminal and add a final commit. And that's it. That's the full circle. Today we saw HTTP requests, middleware and even vision transformers. I hope that was fun. Thank you for your time, and sometime in the future I'll probably make another video where we make a Docker image of an application like this and deploy it using a container registry and an app runner. Until then, bye.